All right, this type of question gonna be a little bit more in like conceptual. So ask you to do synthesis basically. So you have to go backward. All right. So how do you make this compound? So we have aldehyde and we have ketone. All right, start with the aldehyde. The only reaction that gives you aldehyde is the hydration of alkyne with the anti-mechanical fashion. So can you see that this guy right here is a tautomerization product from this compound, eno, right? And if this were to be a triple bond, this OH is attached to the list substitute carbon. This is anti-mechanical product, right? So this reaction is going to come from the triple bond right there. Does it make sense? All right. So you have to be able to look backward. Well, like think about the only reaction that can form aldehyde is the hydration of alkyne. So you have to be able to look at this two carbon right here as an alkyne right there. Add water with the anti-mechanical orientation. So OH go to the less substitute carbon, and then it go to tautomerize to the aldehyde. All right. So what we're gonna do, we take this alkyne, add 9 ppn, and then remove the oxidation. You're gonna get to this. Initially, you're gonna get to this guy first, right? And then we'll tautomerize to the aldehyde that we want. Okay. All right. Same thing down here. So this is ketone. The only reaction that can make ketone is hydration of an alkyne with mechanical orientation. So use the mercury basically. Can you see this guy as an alkyne though? All right, if you can, let's do an enol first. All right, so an enol should look something like either one like this. That's an enol. Could be on the right side, could be on the left side, the double bond. All right, so you got two options there. And if you look at this guy as an alkyne, so enol can be made from alkyne, right? Hydration, mechanical orientation. So go the top one, this triple bond right here, right there. Add OH on here. Okay. The bottom one. So if this were to be a triple bond, you add an OH on right here. All right. All right. So start now. Let's do some synthesis. So start with the top one. So the top one, if you want to make add an OH on it, use the mechanical. So use the mercury. The OH is gonna go on right there at that spot right there. You're gonna get to enol, the first enol first, which will be tautomerized to the ketone. All right. All right. But the second one have a little bit problem. Some of you probably have realized that by now. Both carbon have the same number of substituent. So which one is mechanical orientation? Well, the reagent won't know. I can't tell you either. So both of them have the same number of substituent, one substituent on this carbon, one substituent on this carbon. Right? We don't have like a one substituent, no substituent. You can tell like which carbon is have more substituent, but this one have the same number of substituent. Well, in this case, you're gonna get the mixture. So to make this compound, this compound is a better option. Now you get only one product there. Okay. All right, just be familiar with it. I know this is difficult, all right, but just you got to be familiar with it. Practice some more, and you will be able to see from this to alkyne. All right, so we're gonna take a look at all or summarize all reaction that we have learned so far. Let's see what's going on. Complete the whole thing here. Synthetic map here. The first reaction from here, dialkyl halide, add sodium amide in liquid ammonia. This is elimination, right? Can you see this elimination? And you can also do twice. The waters right here is quenching step. So the carbon right here won't be an alkylate ion. All right, so you get this alkyne. And what is what we do? We do add sodium in liquid ammonia. This is totally do hydrogenation, and you should get trans alkene. But this guy doesn't have trans. It can be trans. There's no substituent on here, so you just get alkene right there. All right. Going to the top, so that's just a regular hydrogenation, hydrogen and nickel, palladium, or platinum. So you should get an alkane. All right. Mercury, you see mercury in sulfuric acid, that's going to be a mechanical hydration, so goes right there. And OH go right there. So you get an enol first, and then we'll tautomerize to a ketone. All right. 9 ppn, that's a bulky borane. This is hydration with the anti-mechanical fashion. So anti-mechanical, the OH is going to go on to the least substitute carbon, that carbon. So you should get this enol, which will be tautomerized to an aldehyde. All right. All right, come down below right here. So excess amount of HBr add on to this alkyne. Alkene can add once, alkyne add twice. Mechanical orientation, you should get that. Next one, where we have HBr and a peroxide. So this one gonna be anti-Markovnikov. So you can add only one. You get a mixture of E and Z isomers. And last one, this one I already showed for you. So add bromine in carbon tetrachloride. That's a solvent. Add bromine multiple times. Add one, so you add one of these to add 2 bromines. Add 2 that is an excess, you get all of them. All right. We haven't learned about this yet, but at least I'm sure you can guess a little. Okay, and that's exciting. What are we gonna learn next? All right, next reaction. All right, before we go further, so we have class activity number 3. We have 5 questions. 6 questions. All right, and then 6 problem, and then the key is right here. All right, next video.